earlier today. And it's something that I'm going to want to at least do some work on to validate if my hypothesis is correct or not. And I'm just going to talk about it a little bit while I eat. So currently, when I render my galaxy volumetrics, I do so by, from the CPU side, baking my density sampling function, my galaxy density function, to a volume texture and pushing that to the GPU asynchronously. This works, but it's not ideal for a variety of reasons. The largest of which is it's really expensive. It's the most expensive part of spawning our galaxy at this point is generating the volume texture. Because we basically have to exhaustively crawl an octree layer and populate an exhaustive grid of density for whatever resolution texture we want to generate, and or produce a downscaled and then upscale it with interpolation. But either way, we have to generate a huge volume texture. And we've done a bunch of optimization to make that as fast as we can. But I was puzzling on a way to add legitimate raymarch volumetrics to the universe layer, which is not the same as the galaxy. The galaxy is bounded. It has a it has boundaries. The universe is unbounded. Baking volume textures for the unbounded universe becomes a very complex challenge. You could do it, but you're going to have to do stuff like bake a large buffer to the GPU, have every cell responsible for updating entries into like portions of that buffer asynchronously. There's a lot of locking, there's a lot of management and HLSL and material work to do. But what if I switch the universe from using a noise derived density function to a hand authored density function that I wrote in C++? Well, now all of a sudden, you can have parity between the C++ density function. You could create an equivalent HLSL density function and just use that directly in your material. And now all of a sudden, you don't have to worry about grids or anything like that anymore. You just have a density function and a distance you want to trace it out to and like a fade out. So that's the end goal, is to basically be able to swap out the sprites that I'm using currently to represent gas at the universe level for a volumetric effect that looks better. But where better to do a proof of concept of that than the galaxy, which is our most mature density function to begin with. So the goal I'm going to be working on today is trying to basically port the galaxy density function I'm currently using on C++ side over to HLSL and create a material that at least will allow us to visualize the output of that density function so that we can tweak it in real time and see the changes directly without having to go spawn a new galaxy and things like that. That's the other benefit here. When it comes to proceduralizing these galaxies, we will have a material with a material instance and a bunch of parameters on it that line up with the parameters the C++ side is using. We will be able to tweak the number of arms, tweak everything in that galaxy shader in real time in the material instance editor, and just mess with the values and find good bounds, good proceduralization, min max bounds, and things like that. Jake, would you stop licking my arm? That is so annoying. Stop. Stop. I'm eating. Stop. Okay. So I had the robot do a conversion to HLSL of my galaxy density function here. And what we're going to be doing is cloning our galaxy ray marcher and attempting to incorporate this. Attempting to incorporate this to replace the volume texture that it's currently sampling. So here we go. Oh, and I finished this star texture, or the star material, which came out pretty good, I think. the temperature-based star material with like sunspots and animation and such. It's kind of churning. Stop. Stop. My dog really wants the burger I'm eating. It's temperature based, so as we reduce the temperature, it changes color. Just a little fun material that I was kind of decompressing working on. Now it's pretty much done at this point. Jake, stop. You are being so annoying. Stop. Stop. He's like, give me your burger or I'm going to lick your mouse and your computer and your hand and your arm and everything you got. I'm going to lick it until you give me that burger you're eating. You can't have my burger, you stupid mutt. You stupid mutt. You can't have it. Okay, so would you stop? I can't use my goddamn mouse. He's like fucking. I put my hand on my mouse and he's like licking my hand and I can't control the mouse. Stop it! Stop it! You're driving me crazy. I'm trying to eat. I'm trying to eat and you're driving me crazy. So step one, I think. Stop. Stop. So annoying. Jake, stop it. Mm-mm. No. Stop. I can't even use the mouse. So step one is going to be a clone. Stop. Step one is going to be to clone this. We're going to need that no matter what. Let's go ahead and rename it. And we'll call this underscore analytic. Because it's no longer going to sample a volume texture. Like it is doing here. But instead, it will be sampling a analytic function. The next thing we're going to need is for this puppy to stop licking my keyboard and my mouse and my hand and my arm. It's a new custom function. Stop! Jake, you're driving me crazy, dude. You're driving me crazy. I can't eat my food. And into this, we will just jam in our robot output that I've got from earlier. This plus this. I can't believe for once the AI got the format of the custom node correct. We'll have to rename all these programs. That'll be up next after I finish eating this burger. So if this works, and I'm perfectly happy to sink a weekend or two into this, but if this works, it's huge. It's so big. Because that means that if this works, we can move to analytic density functions for every ray marcher, for every layer. Okay. That's awesome because it means A, we control the ray marcher, which means that we could introduce things into the material side ray marcher that are not in the density side. So if we wanted to like add nebulas and things like that, we could do it without affecting star creation. But not only that, we cut the entire async texture publishing pipeline out of the entire project. That's very good because A, it's one of the most expensive things we do. B, it relies on deprecated code and like fly by night, like hack together stuff that is not explicitly supported by Unreal. C, it's complicated. like very complicated, hard to understand, hard to maintain. If we can replace, oh, excuse me, if we can replace that with an analytic C++ density function and an HLSL mirror, the level of complexity goes down substantially. The spawn time for all of these elements goes down substantially. The only downside is that sampling a volume texture is cheaper than sampling a complicated analytic density function. So our raymarcher gets more expensive, and that is important and something that we need to be aware of. But I think there's some benefits here that we can reap that will outweigh the performance loss that we get from having to sample the analytic density function versus a volume texture. So our sample gets more expensive, and that's the hottest part of our hot loop, right? Not good. But with a material that's based on a texture that you're ray marching through, generally, you want your steps to be right around the same size as the cells of your texture. So if you have 256 cubed volume material, you want like maybe 256 steps. And that's going to get you a consistent view. Otherwise, you get like sliding and stuff as the textures kind of switch off of, like you move around, you get like sliding and stuff like that. With an analytic function, you don't have that problem. You're measuring against a pure math function that is discrete, so that means it can be evaluated to a continuous value at all points. That means your fidelity goes way, way up because you're not sampling from some downscaled texture that was like blurred and upscaled. You're sampling the direct density function. Not only that, it means that we can do things like adaptive step sizes, less steps, things like that, that I think should more than offset the performance loss from using the analytic function. That's my hope anyway. So that's what I'm getting ready to grind on. I got a couple hours here to work on it. Um, but I and if it's not done by then, it's kind of whatever. What I might do is just set default values for all of these instead of having them assigned to parameters, and then do the parameter step after we're satisfied with the function itself. Um, gonna place this here and comment it out while I finish the last couple bites of my burger. That's lunch sorted out. Just gonna do this. Disk based density 0.5. Disk radial scale length 1.0. Disk vertical fall off 1.0. Arm count 2, 4, 8.8, 0.2, and 0.05 for squash. Oh, wait. I missed one. 0.15, 4.0, 2.0, radial 6.0, 0.5, 0.05, 0.35, 1.5. You gotta relax, my man. Being such a pest. 1.5, background density 0.01, 1, background vertical squash 0.8, background cutoff radius 1, background fade start 0.07, 0.7. Noise power, is that the... Stop, Jake. Jesus Christ. You will not... You're such a little pest sometimes, dude. That's gonna be... here? If I save this, can I preview this? We need to swap to content drawer, inverse. It needs a position input though, right? Oh, okay, so we're missing one parameter, so we'll add that. Inputs, arm, pause. Okay, and that's of course not going to work. So next up, This basically, this function basically replaces, I'm just thinking, let me think about this. Can I, because this is going to be always invisible. Here's what we'll do. Select this, come up here, um, preview. Hmm. Well, still not quite there. So I think we need to wrap this entire thing in a function so that it can be used in our existing raymarcher in place of the texture. So I got to think about that because that's a lot of HLSL. I'm also still eating a little bit. So we don't have a raymarch here. The output, we need like a simple raymarch here. Can we add a method? Same signature. Can we add a raymarch to our struct to debug? City accumulation. Inputs should be the existing params plus just thinking. How much should be the existing params plus what is my plus the same ray march params we use current galaxy ray marcher, ignoring all the other stuff. We just trace the density through an inverted cube. Remarch params slash paradigm. Current guy. We just want to trace all the other stuff. Inverted normal mesh and results so we can see the output in the material. editor. Here is the current galaxy marching paradigm from this. All right, then if I stop previewing, am I able to? Wait, there it is. Grab this. All right, so that is probably over here. Texture 3D to texture 2D. Oh, okay. That's fine. We can fix this. There we go. Flickering like that. Oh well. Okay. This probably won't work directly, but whatever. We definitely want the raymarch. Galaxy density sampler. Okay. There's that, and then we need driver. All right, so now we should be able to start previewing. It's gonna not work probably. Huh? Isn't it happy? Happy. I wonder. Hang on, let's do this. Perfect. Dither. Step size. This should always be derivative, but we'll do step size, and then I guess it'd make more canonical sense to do it like this. The diameter of the object by the number of steps we want to get the step size. Okay, great. Max steps. Per pause. And I want step vector. Vector. And this may need to be flipped. Wait, it got here, huh? Is the last input of the raymarch over here. Okay, we're just gonna have to look at the chat history then. So, I don't know what this means. P6W. What was P6W? Look at the actual function. Noise power. Now wait a second. Now wait just a dang second. It's not rendering properly, but it's not nothing. Okay. This basically validates that I think it is possible to do this. Oh, you know what? What if we flip this? Hmm. Okay, it's off center in the volume. Hmm. That's interesting. So it only worked on the unit box. It is doing the thing. This is going to be fun as hell to play with. Fun as hell to play with when I get this working. This is so sick. So, this is obviously not correct. But it shows a lot of promise because this is our spiral density function. It's it's not centered correctly. It's not filling the volume correctly. Although if this was centered, just putting my thumb up to the screen here. If this was centered, assuming this is the center, it's about this wide. It's a little bit off of from the corner, but if I move that It's almost like a half increment off on X and Y axis. So hang on. What plugs into position in the other one? I think it's. Does this really not take position? I guess it didn't have to. Okay. Okay, that's correct. So it does use the inverse camera vector, I think. And then down here, if I feed local position, it needs camera position somewhere too. Oh, you know what? Hey, I got an idea. It might work. This, this, this. Okay, never mind. There's definitely some assumptions we're making here that are not translating, but for now, it's progress. We have it tracing at least here. So let me see, down here. Local position divided by object radius. What? Oh man, what the fuck is going on here? What if I did... Yeah, but see, this is projected on the surface, which is not what we want. Yeah, this isn't right. Oh shit, you know what? Could it be? Can this whole thing be translucent? Should I just go to like translucent? I don't understand why it's not going transparent for one. Could I? Just thinking, just thinking, just thinking. I don't think we need the dithering at this level. It's analytics, so is it marching the wrong direction? It's too high on the Z, so plus float 3.1.1 negative point 1. Okay, okay. 5. 0.25. I think it's just the raymarch is partially wrong, maybe. Purpose. Debug mode 1. There we go. Yeah, see, like these are all out of the bounds of it. And that's why, okay, I think I know it. So what we're seeing is the intersection with it of whatever face we're like it's not doing the ray march correctly right now, it seems. But this is still useful because this is correct as far as our this is going to be so much easier to iterate on. Oh man, this is going to be great. This is going to be great. All right, I need to go do some stuff, but I'm going to be playing with this the next few days until we have a material that basically does the exact same thing as our analytic sampler on the back end, and then we'll play with that. I think we're going to be able to do some really cool stuff with this, though. Yep, later.